So, few studies have been also conducted by Shaver et al. In 2001 and Kapanoglu et al. In 2002. Based on which Chandrasekharan and Madhuri in 2012, 15, 16 etc. has conceptualized as a preliminary research, and studies very clearly show for various degrees of freedom in surge and sway, Shaver et al. Showed a period of 300.52 seconds. Shaver et al. Also did experimental study and that showed 290.76 seconds, and Chandrasekharan and Madhuri showed results which came to be 300.0 seconds. In heave degree of freedom, this value was 7.97, this value was 9.64 and this came to 9.15. In roll degree of freedom, this was 44.01 seconds, this was 53.46 seconds, whereas this was 53.6 seconds. In pitch degree of freedom, this value was found to be 44.01 and 54.11, and this again showed to be 53.60. In yaw degree of freedom, which is a flexible degree, this was 214.13 seconds. Shaver showed 186.77 experimentally, and of course, they did not report anything of this order. Similarly, when you compare this with Kapanoglu, they showed this value as 148 and this is 158, and based on the same model Madhuri showed it is 148, because the model taken by Kapanoglu and that of Shaver et al. Are different. It is a group of buoyant leg, whereas Kapanoglu identified only single buoyant leg. In heave degree, this was 1.7 and no experimental value by Kapanoglu, and this value became 1.65. In roll degree of freedom, this value was 35.2, this is 29.5, and Chandrasekhar et al. Showed 28.61. So, one can see very clearly here the conceptual model of triceratops generated experimentally and analytically tested by Chandrasekharan et al. Compares well with Shaver et al. And Kapanoglu et al. In the preliminary studies, whereas please note Shaver et al. And Kapanoglu studied this only on buoyant legs, whereas study of this was extended further to form a new generation platform which is triceratops. So, a full model was developed, you can see here the details of the model, and an experimental and model testing were done on both free floating and tethered triceratops by Chandrasekhar et al. For a payload of 4059 tons on a scale of 1:150. So, this was the triangular deck plan which was proposed with 2 deck plates, upper and lower deck plates. Ball joints isolated the deck partially. Buoyant legs were ballasted at the bottom to maintain stability and flotation characteristics desired for a buoyant leg. They were all initially tethered with pretension similar to that of a TLP using 0.3 mm diameter steel tether in an experimental setup. So, for this the structural details in terms of pretension, displacement, ball joint and appurtenances load etc. are available on the screen now for your reference. A further study is then extended to a water depth of 600 meters for a scale of 1:150, and experimental studies were performed to understand the response behavior. So, for a water depth of this, a design draft was established and dimensions and initial pretension values and all structural characteristics of the platform for a scaled model compared to prototype in terms of tethered triceratop and free floating are available on the screen now for our discussion. The free flotation characteristics showed that the free floating triceratop had heave degree, roll and pitch degree of freedom frequencies as 20.3 seconds in terms of period with 0.7% damping. In roll it was 98.5 with 6.1% damping. The tethered triceratop showed better vertical stiffness, therefore, in heave degree of freedom it showed 5.8 seconds with 2.7% structural damping. Of course, in surge and sway it showed 146 seconds with about 10.4% structural damping. So, details of the model are shown on the screen now, and these are the natural periods and damping of the platform conceived for free floating and tethered triceratop under installed conditions. More details of this study can be also seen from the reference papers of Chandrasekhar et al., which has been given in the NPTEL website of this particular course. Interestingly, we understood that partial isolation controls displacement to a larger extent, especially in roll and pitch. To verify this statement, I request you to please go through the experimental and numerical papers published by Chandrasekhar et al., which references are given in the NPTEL website of this course. You will verify the statement by reading those papers. But I have a different observation. The observation is, though the deck response is partially isolated, but still buoyant legs showed large displacements under rotation. Can we control that? Can we integrate the motion of all the buoyant legs together? So, that was also examined by interconnecting the buoyant legs with 3 legs together, and each leg has got 3 groups of buoyant legs and each one of them are connected. However, each buoyant leg remain independent. Okay. So, the structural characteristics of this model at the scale of 1:72.41 to be very specific is given on the screen. So, the structural characteristics and geometric characteristics of the platform which are attempted new are also shown in the screen at this moment, and this study showed a very interesting phenomena of advantageous features. So, this is the plan of the triceratops model installed in the wave maker, the wave basin. This is the instrumentation plan and this is the photograph of the experimental study, for which now I will show you a video. Please observe the video on the screen at this moment. It is a triangular deck with the legs, buoyant legs are connected to the deck using a ball joint. Wave is hitting the legs, legs are rotating about this pivotal point, but you can see here the deck remains almost horizontal. It means the roll and pitch motion of the buoyant leg are isolated to get transferred to the deck, which is the advantage of the whole system design. So, deck is partially isolated, legs are strengthened by intermediate stiffeners. This showed better response characteristics. So, if you compare the tethered triceratops in heave motion, surge and sway motion, you will see that the periods have come to 88.4 with 8.2% zeta. In heave has come to 1.8 seconds, it has become more stiff with 1.1% structural damping. When you compare these values with the earlier periods what I gave you for an independent buoyant leg triceratops, they showed more stiffening in vertical plane and reduced frequency or time period, in sense more stiffness in horizontal plane as well, which is a great advantage as far as the structural form is concerned. So, friends, let us quickly write down the summary what we have learned in this lecture. This lecture focused on new generation platform, the concept was conceived from an idea called buoyant legs, which was assembled to form a triceratops which is suitable for deep and ultra deep waters. The structural geometry showed advantageous behavior. Now, the deck can be isolated to control its response. So, friends, offshore structures has got form dominance in its design, which shows advantages which should be taken care of when we do the analysis. Unlike conventional structures, offshore structures should have a form uniqueness to do the analysis. This is the important concept what we wanted to establish from the set of lectures what we so far discussed in module 2. Next lecture we will move on to environmental loads, we will discuss about the programming, how to work out environmental loads, etc. Thank you very much.